A very warm welcome to all. My name is Vinita Chaudhary. I am from BTech ITDS from Division A. For assessment 4 of BEEE, I have chosen the topic of PN junction diode. So in this topic, I have covered some following points. The first one is PN junction diode. The second one is physical operations of a PN junction diode. After these, biasing conditions in PN junction diode, characteristics of a PN junction diode, and the last one is application of the diode. Okay, so let me see what is a PN junction diode. First of all, we see this diagram. In this diagram, there are two types of semiconductors are there. The first one is P-type semiconductor and the other one is N-type semiconductor. So P-type semiconductor are contain anodes and N-type semiconductor are contain cathodes. So basically, when P-type semiconductor is joining with N-type semiconductor and they both are separated by a thin junction, which we call a PN junction diode or junction diode. So P-type semiconductor are contain holes and N-type semiconductor are contains electrons. So let's we move now. Current flow in N-type material. Let us see what happen if we connected a battery across a N-type semiconductor as shown in figure. A free electrons and holes experience the force towards the battery terminals. The free electrons will tend to move towards the positive terminal of the battery. Holes are also apparently shifted from one covalent bond to other towards the negative terminals of the battery. Thus, a movement of free electron take place in direction of opposite to that hole movement, right? So, therefore, in N-type semiconductor, the current flow due to the movement of free electrons and holes. Since the free electrons begin the majority carriers and the holes begins the minority carriers, the net current will be due to the majority carriers, that is free electrons, right? So now when we connect a battery across a p-type semiconductor, let us see that what happened. A free electrons and holes experience a force towards the battery terminals. A free electrons will tend to move towards the positive terminal and jump into available holes of boron atoms, right? Since the free electrons are not available in p-type semiconductor, therefore electrons that are moving towards the positive terminal come from covalent bonds. This tendency of electrons to leave the covalent bond is due to the fact that holes are available in front of them, right? So, in electrons from one covalent bond jump into the hole in front of it, thus leaving a hole in the covalent bond it has left. These electrons now jump into the next available hole and so on. As this process continues, it is apparent that holes are shifted towards the negative terminal of the battery. It should be noted that in p-type semiconductor, free electrons are simply transferred from covalent bond of one atom to the neighboring atom. Thus, movement of positive charges take place in a direction of opposite to that of free electrons movement, right? So let's we move towards a junction bias. In N-type material, losses of an electron create a positive ion in that material, while the losses of a hole from P material created a negative ion in that material. These ions are fixed in a crystal lattice structure and cannot move. Thus, they make a layer of a fixed charges on the two sides of a junction as shown in a figure, okay, in above figure. So on N side of a junction, there is a layer of positively charged ion. On the P side of a junction, there is a layer of a negatively charged ion. So the diffusion of electrons and holes across the junction will continue until the magnitude of electrostatic field is increased to the point where the electrons and holes no longer have enough energy to overcome it. At this point, equilibrium is established and all practical purpose the movement of carriers across the junction cases For this reason, the electrostatic field created by a positive and negative ions in the depletion region is called a barrier. So now we see the biasing conditions in PN junction diode. So there are basically three biasing condition in PN junction diode. So the first one is zero bias. In zero bias, there is no external voltage applied to a PN junction diode. And the other one is forward bias. So in forward bias, the positive terminal of voltage potential is connected to the P type, while negative terminal is connected to the N type. And in reverse bias, negative terminal of voltage potential is connected to the P type and positive is connected to the N type. So it is as easy as we see. So we proceed towards the characteristics of a PN junction diode. Now, basically, the most important point to remember about PN junction diode is its ability to offer a very little resistance to a current flow in the forward bias direction, but maximum resistance to current flow when reverse bias. A good way of illustrating this point is by plotting a graph of applied voltage versus the measured current. The figures show a plot of this voltage current relationship, basically which we call the characteristic curve for a typical PN junction diode. Now let's see this diagram. In this diagram, a PN junction diode acts as a rectifier. So in this diagram, a curve drawn between voltage across the junction along with x-axis and current through the circuit along with y-axis. So they describe a DC behavior of the diode. When it is a forward bias, no current flow until the barrier voltage is overflow. Then the curve has a linear rise and a current increases with the increases in forward voltage like an ordinary conductor. Therefore, the forward current increases sharply. Now we move towards the application of PN junction diode. Until now, we have mentioned only one application for a diode rectification. But there are many more applications that we have not yet discussed. Variations in doping agents, semiconductor materials, manufacturing techniques have made it possible to produce diode that can be used in many different applications. Example, they use as a rectifier to convert AC to DC current. As in switch in computer circuit, they use as a detectors in radios to detect audio signals and as LED to emit different colors. So here I am done with my presentation. Thank you.